Welcome to Module 3 of the Mali GPU training, where we will look at how to analyse performance with Arm Mobile Studio. In this section, we will introduce some of the benefits you can gain from having a strong optimisation process, and how Arm Mobile Studio could enhance your existing development workflow. Arm Mobile Studio is our performance analysis tool suite, specifically designed for Android application developers. It can help you quickly identify problems in your application that might cause it to run slowly, overheat the device, or quickly drain battery. The tools capture the CPU activity, GPU activity, draw calls and content metrics of your game as it runs on a non-rooted Android device. Once you identify areas of your game that are causing performance problems, you can optimize it using the best practices introduced in the previous module. You can use Arm Mobile Studio to analyze graphical content and native code for devices that have Arm CPUs and Mali GPUs. Because Arm partners with the companies that design and manufacture mobile devices, we work directly with them on what the system software can do, so our tools can give you a lot of visibility around how an application performs on those devices. The tools can see native code, system event trace from the OS scheduler, and event trace from the application itself. You can add your own annotations to provide context. We get all the hardware counter data from the CPU, GPU and caches, plus content analysis on the API side for the GPU and shader programs. Arm Mobile Studio provides a very rich data source to help you solve a variety of different kinds of problems. If you're a GPU expert, then you can delve into the data to find what you need. If you're not, then these tools can help take the pain out of performance analysis by presenting this data in a human-readable format and generating actionable advice for your development team throughout the development cycle. There are three main use cases for adopting a good performance analysis workflow. The first is about player retention. When you release a new game into new markets on new devices, how do you ensure that your gameplay is smooth and you're not flattening the user's battery within a couple of hours? If frame rate is above 30 FPS and gameplay is smooth, users will keep playing for longer. When frame rates drop below 30 and games start to stutter, users will just uninstall it. Next, how can you adapt a game to perform well on a device that doesn't have the latest capabilities? In order to reach new players, you quite often need to target mass-market handsets, which are usually less capable in terms of performance. You might initially release your game to target a small number of high-end devices, and then, once it's proved that the game is viable and has a market, you can aim to increase player numbers by expanding support to a wider range of devices. And lastly, if you are targeting high-end phones, how do you get console-quality graphics but inside that 2 to 3 watt power budget on mobile? Where can you optimize to make headroom for more sophisticated visual effects? Arm Mobile Studio is supported on Windows, macOS and Linux and is free to download from the Arm developer website. Streamline captures a comprehensive performance profile of your application to help you understand how the workloads from your game are handled by the device. It lets you deep dive into problem areas by visualizing the performance counter data from the CPU, GPU and memory system. Performance Advisor gives you an easy-to-read report with a summary of overall performance, including whether the application is bound by the CPU or the GPU, and actionable advice on how to optimize your application. It takes the captured data from Streamline and presents it alongside per-frame content metrics to create a developer-friendly snapshot for quick analysis. Designed to be consumable for non-experts, Performance Advisor reports are useful for a daily health check to ensure performance stays on track during development. With Graphics Analyzer, you can capture every OpenGLES or Vulkan graphics API call to inspect exactly what happened during a problematic scene. See the frame buffer output alongside the object geometry to evaluate the impact of each draw call and whether the size and complexity of objects on screen is appropriate. You can analyse overdraw, shaders, textures and fragment counts, draw call by draw call, to find opportunities to optimise performance. Mali Offline Compiler lets you test how your shader programs would perform on any of the available Mali GPUs. It gives you full visibility of the true processing cost of each shader and its impact on game performance. You get a breakdown of cycle costs for the major functional units, stats for register and stack usage, and a health check on shader properties, such as whether the shader has any uniform computation or side effects, or uses late ZS testing. One challenge we have is that Android doesn't guarantee any level of data availability. Software profiling through Android Studio Systrace is part of the Android stack, but the data for GPU counters, CPU counters, and power management, for example, is only available if the device manufacturer chooses to expose that data. Most do, but it's not universally accessible. This imposes some limitations on the range of devices that Arm Mobile Studio supports fully, so we publish a list of supported devices on our website. Arm Mobile Studio Starter Edition is free to use and has all the performance analysis features you need to profile and debug interactively. If you get stuck, help and support is available through our developer community forum for graphics and gaming. The Professional Edition provides a scalable solution so that you can build the tools into a continuous integration workflow to automatically generate nightly reports and captures that your team can evaluate every morning. You can also push the data in machine-readable JSON format to a database and visualization platform so you can build performance dashboards to monitor performance over time. Also with Professional Edition, you get access to dedicated ARM support engineers to assist you via the ARM support portal. Ideally, you want to monitor performance regularly throughout development to check how you are scoring against your performance or power targets when there is still time left in the development cycle to make changes. Some studios are using continuous integration and automated testing across multiple devices to automate this process, but the majority are still using human playtesters to report issues. As devices get more numerous and content gets more complicated, relying on manual testing for validating performance might not be sustainable. Arm Mobile Studio reduces the barrier to entry by providing tools for manual analysis, but with the option to extend those tools into a CI workflow as studios expand their test suites. The workflow is a multi-stage approach. First, monitor a game scenario with Streamline and generate a high-level summary with Performance Advisor. Here, you'll quickly learn where the FPS was on target or below target, which parts of the game were CPU or GPU limited, whether slow content was vertex or fragment heavy, and if overdraw was high. You can often draw easy conclusions for the majority of problems at this stage just by looking at these high-level reports. You can share these reports with the rest of your team on a daily basis so that they can quickly get optimization advice without being a performance expert, without doing any deep dive analysis or needing access to devices or builds. With the Pro Edition, you can also build a performance dashboard using Grafana, Kibana, or any tool that can consume JSON files to track performance changes over time. If you find problems that aren't obvious to solve and need further investigation, then that's where our Streamline Profiler comes in. Here you can analyse the counter activity data in much more detail to see exactly how the device handled the workload. Streamline is a fully fledged native code profiler, so if you have bottlenecks in native code and you've got a debug binary, you can use the hotspot profiler in Streamline to dive in. To debug API calls, you would use Graphics Analyzer to capture slow areas of gameplay and then explore the API sequence to see what behaviour might be causing the slowdown. If you find shader problems, you can run a lightweight static analysis on your shader programs with Mali Offline Compiler. Some technical artists also like to perform a monthly review, where they grab a few frames and do a teardown to report back to the team. This enables you to give feedback, such as how the game translates into render passes and draw calls, and what the art assets are doing. Future tooling will look at how to help automate this process, as this can be quite time-consuming for a small studio with multiple titles on the market. Done properly, optimization is a science, but it's hard to manually recreate the same game scenario twice, so you need some scientific methodology around how you track performance. A good way to do this is to have a library of reproducible playtests that are representative of the game workloads, so that you can compare the same content over multiple runs. It's useful for any studio, but becomes more important if you are using CI to automate captures, so you can run a series of reproducible performance tests through your device farm every night. In the next section, we'll look at the tools in action, starting with Performance Advisor.